In Chapter 6 we'll be dealing with radian measure and its applications. Nearly everything in this chapter will be dealt with in radians, so the first thing you'll need to be able to do is convert. 1 radian is equal to 180 degrees over pi, and 2 pi radians is 360 degrees. An easy way to convert is by pressing Shift Answer on your calculator. From here you'll be able to convert from radians to degrees and degrees to radians with ease. You'll need to know 3 formulas for this chapter. On their own they'll be worth an easy 1 or 2 marks. However, when used in conjunction with each other, triangle laws and laws of angles within circles, this is when problems may arise. The first of these 3 formulas which you'll need to know is the arc length L is equal to r theta, where r is the radius and theta is the angle that subtends the arc in radians. Questions involving this formula often require you to remember that the angle at the center of the circle is twice the angle at the circumference. Also, you'll need to remember this formula for working out the perimeter of a sector, which is 2r plus r theta. And finally, it will be useful to bear in mind that if r and the arc length are the same, then the theta will be 1 radian. You'll need to be able to prove all 3 of these formula. For L equals r theta, we know that the length of the arc divided by the circumference of the whole circle has the same ratio as the angle subtending the arc over the whole angle of a circle. So L over 2 pi r equals theta over 2 pi. Here the 2 pi's cancel, leaving us with L over r equals theta. This can be simply rearranged to L equals r theta. The second formula you'll need to know is A equals half r squared theta. This gives you the area of a sector. It does come up more frequently than L equals r theta on its own, but should still be an easy 2 marks. When combined with other formula, triangle laws and laws of angles within circles is when it might become a little bit tricky and be worth 5 marks. If you practice a few though, it shouldn't be any problem. The proof of this is pretty similar to L equals r theta, except instead of using the length of the arc, we use the sector area and put that over the total area of a circle, which is a over pi r squared. This should be equal to the sector angle over the total angle of a circle, so theta over 2 pi. When we multiply both sides by pi r squared, the pi's cancel and we're left with a equals half of r squared theta. The final formula you have to know is for an area of a segment. A segment is an area enclosed by an arc and a straight line going between the 2 ends of an arc. The formula for this area is a equals half r squared theta minus sine theta. Again, on its own, it might be worth perhaps 2 marks and shouldn't really be a problem. However, you have to remember all 3 of these formula, as they aren't in the formula book, and you have to use them in conjunction with triangle laws and laws of angles within circles. However, if you practice as many 5-mark questions as you can, there should be no problem. The proof for this formula is slightly different. The area of the whole sector is half r squared theta, and the area of the non-shaded triangle is half r squared sine theta. We get this from half AB sine c. As r is both a and b, this becomes r squared, and sine c is just sine theta. The whole sector minus the area of this unshaded triangle gives the area of the minus segment. So, half r squared theta minus half r squared sine theta factorizes nicely to half r squared theta minus sine theta.